From the depths of the ocean to the vast reaches of space, and even some quirky corners of everyday life, these incredible truths are guaranteed to make you question everything you thought you knew. So sit back, relax, and prepare to be amazed, because truth really is stranger than fiction.
Time zones create an interesting quirk in the way we experience time, making it possible for someone to celebrate their birthday twice in one day. The Earth is divided into 24 time zones, each generally 1 hour apart, though some have half-hour or even 45-minute differences. Because of this, different parts of the world experience the same calendar date at different times. This means that if a person were to travel backward across time zones after celebrating their birthday in one location, they could reach another place where their birthday is still ongoing. For example, imagine someone celebrating their birthday in Japan, which is ahead of many countries in terms of time. If they then boarded a flight to Hawaii, which is many hours behind, they would land in a place where their birthday is still happening according to the local time. This allows them to extend their celebrations and, in a way, relive part of their special day. This phenomenon isn't just limited to birthdays, it applies to any significant event based on dates, including New Year's celebrations. Some travelers even plan trips specifically to take advantage of this time zone trick, ensuring they get extra hours to enjoy their big day. It's a fun and unique way to bend time, at least from a human perspective, and make the most of a special occasion.
The word alphabet has its roots in the Greek language, specifically from the first two letters of the Greek alphabet, alpha and beta. The term alphabet itself is a combination of these two names, reflecting the fundamental building blocks of written language. This connection highlights the deep influence of ancient Greek on modern linguistic concepts, especially in the development of writing systems. The Greek alphabet, which dates back to around the 8th century BCE, was adapted from the earlier Phoenician script. The Phoenicians, a seafaring civilization in the Mediterranean, used a consonant-based writing system which the Greeks modified by adding vowels, creating one of the first true alphabets. This system greatly influenced the Latin alphabet, which is the basis for English and many other languages today. The impact of the Greek alphabet goes beyond just the word alphabet. Many modern terms, especially in science and mathematics, still use Greek letters such as pi in mathematics or omega in physics. The influence of this writing system has shaped the way languages are written and structured, making it a foundational part of global communication.
Unlike the other planets in our solar system, Earth is the only one that is not named after a god from mythology. The names of the other planets, Mercury, Venus, Mars, Jupiter, Saturn, Uranus and Neptune, are all derived from Roman deities, reflecting the influence of ancient Roman and Greek culture on astronomy. For example, Mars is named after the Roman god of war due to its reddish, blood-like appearance, and Jupiter, the largest planet, is named after the king of the Roman gods. The name Earth comes from Old English and Germanic origins, rather than mythology. The Old English word Eorda and its Germanic counterpart Erda both meant ground or soil. Unlike the other planets, which were named by ancient astronomers who studied them as celestial bodies, Earth was historically seen more as the land people lived on rather than a planet in space. Since early civilizations didn't initially recognize Earth as a planet like the others, it never received a name based on a god or deity. It wasn't until later scientific advancements that Earth was fully understood as a planet in its own right, orbiting the Sun just like the others. By that time, the name Earth was already deeply rooted in language and culture, and no mythological renaming occurred. This makes Earth unique not only in its ability to sustain life, but also in its name, which connects it more to the ground beneath our feet than to the divine figures of ancient mythology.
Light, while famously fast, does not always travel at the same speed. In a vacuum such as space, light moves at approximately 299,792,458 meters per second. This is considered the universal speed limit. However, when light enters a different medium such as water, its speed slows down by about 25% due to a phenomenon known as refraction. This slowing occurs because water is denser than a vacuum or air. As light waves pass through water molecules, they interact with the particles, causing the waves to scatter and effectively slow down. In water, light travels at roughly 225 million meters per second, which is significantly slower than in air or space. This effect is what causes objects to appear distorted or bent when viewed underwater, a classic example of refraction. The slowing of light in water has important real-world implications. For example, it affects underwater optics, meaning that divers and marine life experience a different perception of light and color. It also plays a crucial role in fiber optic communications, where light signals are transmitted through glass or water-based mediums, and understanding how light slows down helps optimize data transmission. Interestingly, different materials slow light down by varying amounts. Diamond, for example, slows light down even more than water, reducing its speed by nearly 60%. This property is one reason diamonds have their signature sparkle. Light bends and reflects internally before exiting. The fact that light isn't a constant speed everywhere, but rather changes depending on the medium it's traveling through is a key principle in physics, helping scientists better understand the behavior of light and energy.
The idea that another Earth-like planet could exist somewhere in the universe isn't just science fiction. It's supported by mathematical probability and astrophysical observations. Given the vastness of the cosmos, with hundreds of billions of galaxies, each containing hundreds of billions of stars, the chances of another planet similar to Earth existing are statistically quite high. Scientists estimate that there could be trillions of planets in the observable universe, making it likely that some of them have conditions similar to those of Earth. One of the key factors in finding another Earth-like planet is the Goldilocks zone, or habitable zone, which refers to the region around a star where conditions are just right for liquid water to exist. Since liquid water is essential for life as we know it, planets in this zone have a higher chance of supporting life. According to NASA's Kepler Space Telescope data, there are potentially billions of exoplanets, or planets outside our solar system, in habitable zones, some of which are Earth-sized and orbit stars similar to our Sun. Mathematically, scientists use the Drake equation, a formula that estimates the number of civilizations in our galaxy by considering factors like the rate of star formation, the fraction of stars with planets, and the probability of life developing. While the equation doesn't give an exact number, it suggests that Earth-like planets capable of supporting life may not be rare. Additionally, astronomers have already discovered promising candidates such as Kepler 452b, Proxima Centauri b, and TOI 700d, which are located in their respective habitable zones and have characteristics somewhat similar to Earth. However, confirming whether these planets truly resemble Earth in terms of atmosphere, water presence, and life-supporting conditions requires further study with advanced telescopes like the James Webb Space Telescope, or JWST. In summary, while we haven't yet found an exact replica of Earth, mathematics and probability strongly suggest that such a planet exists somewhere in the universe. With continuous advancements in space exploration, the discovery of a true Earth twin may just be a matter of time.
The small dot above the lowercase letter I, and also the letter J, is called a tittle. This tiny mark may seem insignificant, but it plays an important role in typography and language. The word tittle comes from the Latin word titulus, meaning inscription or heading. Over time, it evolved into a term for small marks or strokes in writing. The tittle helps differentiate lowercase I and J from similar-looking letters, especially in handwritten or cursive scripts. Without it, these letters could easily be mistaken for L or other characters, causing confusion in reading and writing. The introduction of the tittle made texts clearer and more legible, especially as writing styles evolved over centuries. Historically, not all alphabets or writing systems included a tittle. In early Latin and medieval manuscripts, scribes often wrote I without a dot, especially when it appeared next to tall letters like M or N. The dot became more standardized with the development of the printing press and modern typography, ensuring consistent and readable text. Beyond its practical function, the tittle has also found its way into language and culture. The phrase to dot your I's and cross your T's means paying close attention to detail, emphasizing the importance of even the smallest marks in writing. While often overlooked, the humble tittle is a small but essential part of written language, helping maintain clarity and distinction in words.
Lightning is one of nature's most powerful and frequent phenomena, striking Earth approximately 8 million times every day, which translates to about 100 lightning bolts per second worldwide. This incredible frequency occurs because thunderstorms are constantly forming across different regions of the planet, especially in areas with warm, humid air, where atmospheric conditions are ideal for electrical discharge. Lightning forms when static electricity builds up in storm clouds due to the collision of ice particles and water droplets. This creates a charge imbalance, with negatively charged particles accumulating at the bottom of the cloud and positive charges forming on the ground. When the charge difference becomes large enough, a sudden electrical discharge occurs, resulting in a lightning bolt that can travel at speeds of 270,000 miles per hour and reach temperatures hotter than the surface of the sun, up to 30,000 Kelvin. While lightning can occur anywhere in the world, some locations experience far more strikes than others. Lake Maracaibo in Venezuela holds the record for the most lightning activity, with storms occurring more than 260 nights a year. Similarly, regions near the equator, such as Central Africa and Southeast Asia, see frequent lightning due to their warm, moist climates. Lightning is not just a spectacular natural event, it also has significant impacts on the environment and human life. It can ignite wildfires, cause power outages, and even pose a risk to people and buildings. However, it also plays an important role in nature by helping to produce nitrogen oxides, which contribute to the nitrogen cycle, enriching soil fertility. With advanced meteorology and lightning detection systems, scientists can now track lightning activity in real time, helping to predict severe weather and reduce risks. Despite its dangers, lightning remains a fascinating and essential part of Earth's natural processes, shaping the planet in ways both seen and unseen.
Email has become one of the most dominant forms of communication in the digital age, with a staggering 240 million emails sent every minute worldwide. This number highlights just how central email is to modern life, whether for personal messages, business communications, marketing, or even spam. With billions of people using email daily, it remains a crucial tool for staying connected in both professional and personal settings. The rapid rate of email transmission is made possible by the vast network of servers and internet infrastructure that supports digital communication. Emails travel almost instantaneously through data centers and cloud-based systems, ensuring that messages reach their recipients in seconds. Popular email services like Gmail, Outlook, and Yahoo Mail handle a significant portion of this massive email traffic. However, not all emails are meaningful human interactions. A large percentage of emails sent every minute consist of spam, promotional messages, and automated notifications. In fact, spam accounts for over 45% of all email traffic, making cybersecurity and spam filters essential for protecting inboxes from phishing scams, malware, and other threats. The sheer volume of emails also raises concerns about data storage and environmental impact. Large-scale email servers require immense amounts of energy to operate, contributing to the overall carbon footprint of the internet. Simple actions like reducing unnecessary emails, unsubscribing from mailing lists, and deleting old messages can help minimize digital waste. Despite competition from instant messaging apps and social media, email continues to thrive as a primary form of communication. Its reliability, formal structure, and ability to send attachments make it indispensable for businesses, education, and official correspondence. With billions of users worldwide, email remains a cornerstone of the digital world, evolving alongside technology to meet the demands of an increasingly connected society.
The idea that folding a piece of paper 42 times would allow it to reach the moon sounds impossible at first, but it's a fascinating example of exponential growth in action. The reason behind this mind-blowing fact lies in how paper thickness doubles with each fold. Even though a standard sheet of paper is only about 0.1 millimeters thick, repeated folding causes its height to grow at an astonishing rate. Each time you fold the paper, its thickness doubles. After one fold, it's 0.2 millimeters thick. After two folds, it's 0.4 millimeters thick. After 10 folds, it's about 10 centimeters or 4 inches thick. After 20 folds, it reaches 10 kilometers or 6.2 miles, already higher than Mount Everest. By 42 folds, the paper's thickness surpasses 384,400 kilometers, or 238,855 miles, the average distance from Earth to the Moon. This mind-bending concept is a perfect demonstration of exponential growth, where numbers increase at an accelerating rate rather than linearly. It's the same principle behind rapid population growth, compound interest, and even the way viruses spread. However, in reality, folding a piece of paper 42 times is nearly impossible due to physical limitations. Standard paper quickly becomes too thick and rigid to fold beyond 7 or 8 times, even with large sheets. The current world record for physically folding paper is 12 times, achieved with a giant sheet of ultra-thin material. Despite these real-world limitations, the math behind it is absolutely correct. This thought experiment serves as an incredible way to visualize how quickly numbers grow exponentially and helps us appreciate the surprising power of mathematics in understanding the universe.
In today's digital age, photography is more accessible than ever, and the number of pictures we take is staggering. Every 2 minutes, people around the world take more photos than all of humanity did throughout the entire 19th century. A fact that highlights just how drastically technology has changed the way we capture and preserve memories. During the 19th century, photography was a new and rare innovation. The first permanent photograph was taken in 1826 by Joseph Nicephore Nips, using a method called heliography. Early cameras were bulky, required long exposure times, and used complex chemical processes. As a result, taking photographs was expensive, time-consuming, and limited to professionals or the wealthy. By the late 1800s, with the invention of George Eastman's Kodak camera, photography became more accessible, but it was still nowhere near today's levels. Historians estimate that the total number of photos taken in the 19th century was in the millions, a tiny fraction compared to modern photography. Fast forward to today, and smartphones have completely revolutionized photography. With billions of people carrying high-quality cameras in their pockets, taking pictures has become instant, effortless, and free. Apps like Instagram, Snapchat, and TikTok encourage people to snap and share photos constantly. It's estimated that more than 1.8 trillion photos are taken each year, averaging about 5 billion photos per day. In just 2 minutes, we now capture more images than the entire 19th century combined. This explosion of photography has changed everything, from how we document history to how we interact with the world. While early photographs were rare and precious, today's images are often fleeting, stored in digital formats, and sometimes forgotten in vast online archives. The ease of taking pictures has made photography a part of daily life. But it also raises questions about privacy, digital clutter, and the value of an image in a world where pictures are endless. Nonetheless, the fact that we now take more photos in 2 minutes than in an entire century is a testament to how far technology has come. From a single blurry image in 1826 to billions of high-resolution selfies every day, photography has evolved into a universal language that shapes our culture, memories, and storytelling in ways the pioneers of the 19th century could never have imagined.
Thank you for watching. We hope these mind-blowing facts left you amazed and inspired. Don't forget to like, subscribe and hit that notification bell because there's plenty more where that came from. Stay curious and we'll see you in the next one.